Hello everyone, welcome back to my computer project. Last week I mentioned that I would be working on a simulator or emulator for this project so that I can write programs for it without actually having finished the actual machine yet. So this is that. I started working on it on Monday, so it hasn't had much love, but it works. So I've got several example programs here and variable clock speeds, run, reset, pause. Run basically compiles it and outputs it, and reset just doesn't change anything that's put in memory. So if you write a program that changes memory, then you click reset, it only resets the program counter. So that could be helpful for certain things. Pause, resume, and yeah. So this is where you write your program, and this is the program in binary format. So this is what would actually be in memory. And this is the program in octal, which is what I would primarily use for putting the program in through the front panel. This is where the hex would be displayed, but hex isn't that important. It's just if I wanted to read back from the machine the correct values, that's what it would display. So yeah, we'll have a look at the addition program here. It's doing 4 plus 7, as it's already got the answer there, but you'll see it has to tick through several bits to get to that. One thing I will note is that I don't actually simulate the control word or instruction cycle, anything like that. This is just, there's literally a function for each instruction. So it's not perfect yet, and I'm going to add that. So you'll be able to see the control word change and all that stuff. And you'll see it you see the bus and these inputting and outputting directly from that. So it'll be a lot more detailed, and this won't jump around so much. This will be a lot more detailed as well. Oh yeah, so this is meant to be synonymous with what's actually in the machine. So you have the program counter, registers, memory address register, and memory. There's a few more things I mean to display here. I just haven't done it yet. And this is displaying all 256 bytes of memory. Initially I'll only have 16 though, so that'll be roughly here. So these programs will work. Some of these programs will work. Like addition will work. I've got subtraction here, which is 57 minus 17 outputs 40. So that will work. Counting will work. So this just goes from 0, or it actually goes from whatever's already in memory in register A and just counts up. Also, I'll show you the clock speed here, so you can bump that up. And what else do we have? We have two types of Fibonacci sequence here, just different ways of writing it. So this version uses load and store functions. So this is using a lot of memory access, so it has to read and write to memory a lot. So it's not fast, but it works. And Fibonacci 2 actually uses some different instructions, set A and set B. So you don't need to give it a memory address, you just give it a direct value. So no reading writing from memory. Direct adding, so whatever's already in register A and register B, which we've just set here, those will be added, so you don't need to access memory for that either. And swap just swaps the values of A and B. Because A is essentially the accumulator, with the help of register C here, because it's a bit hacky. But yeah, so register A is basically the accumulator, so it gets the value out of the ALU, and you swap them so you always have the last one and overwrite the last one, which you don't need anymore. And that's essentially how that works. And this one's a little bit faster, you'll see here. It takes up a lot quicker. It's because it doesn't need to go in and out of memory at all. Other things I did were a little program that just fills RAM with, the address. It gets the address and writes the address to that address. This one, you'll see here, is currently has a 2 in the first byte here. This doesn't know when it gets to the end, so when it gets round, it just overwrites that. Yeah, so then it bugs out. I think 0 is no op, but then it goes to 7, which is actually an operand, but it treats it as an instruction because it just had a no op. And yeah, I think 7 is probably jump or something because it's going all the way over here. So it's actually doing jump to whatever add is, which isn't ideal, but that's to be expected from that program. Other program we got is the multiplication. So I'm struggling to talk here, my lips are really dry, and my throat. But yeah, this does 5 times 10. As you can see, it's doing stuff here. So what this is actually doing, and there you go, you get 50. So it takes the 5 and it keeps adding, well, it has a 0, keeps adding 5 to it, and it has a running total, and it takes the 10, takes 1 away from it every time, and eventually when 10 gets to 0, it hits this, which is jump if 0, then that jumps to here, which outputs it to the display register and halts. So it'll just keep doing that until it gets to 0, and then the value that you've been adding up to will be the value of the multiplication. So yeah, that's that. I'm actually going to release this today, so it'll be in the description of this video. So if you want to play about with actually writing programs for this, that would be really cool to see some interesting things. Yeah, you've got the reference down here. So these are all the instructions that are currently built into it, and some notes on just what's missing and what I'm going to be adding. Like I said, I've been doing this since Monday, so it hasn't had much work done on it. Yeah, so it will be uploaded on GitHub. You'll be able to actually run it there as well. And yeah, I think you can probably write issues and stuff to post programs or something. I don't know how that half of GitHub works, but yeah, that's the simulator. And this should be a decent stopgap for the time being, and actually be able to get stuff running, and things like addition and subtraction programs. They don't actually take up that much memory. It's like 1, 2, 3, 4, 5, 6, 7, 8 bytes. So once I have 8 bytes, I can actually skip the rest of the RAM for now and just start on the sequencer and actually get programs like this running. Actually, that's running so quickly, I think it doesn't get to see it. Yeah, so I can get programs like that running, which isn't amazing, but it is a computer at that point, isn't it? It's got a program, it's running it, it's getting a result. That's the definition of a computer to me. So yeah, check out the link in the description to actually try this out, and thank you for watching, and I'll see you later.